As we start our next to last section in Math 1103, Section 5 of Chapter 5, we're going to deal with negative exponents and scientific notation. Now, I had given you a little thumbs up earlier in the lesson that when we have, let's say, a to the negative n, what does that mean? Well, we said we take this from the numerator, this negative exponent, bring it down across the division bar, and the sign changes. So these are equivalent. And we're going to use that rule of moving the exponent across the division bar. When we would bring it up, it would become a negative exponent. So we now have some examples. And keep in mind that these are like all over 1. And in a sense, there's a 1 times that up in the numerator. We just don't write those 1s. So here, the 1 will stay up in the numerator. The 3 to the negative 2 comes down as 3 to the second. And then that simplifies to 1/9. Now in example B, here's where some students get a little nervous or possibly can make an error. What is the base of that negative exponent? And it is only the x. So the 2 stays up in the numerator and the x comes down and it changes the sign of the exponent. Now in letter C, this is actually another way to show 1/2. That is times 1, the 2 comes down, and it now has a positive exponent of 1 in the denominator. Again, we don't write those. And then this becomes plus 1/4. So now we have a little fraction example. We want to make common denominators. So we're going to multiply this by 1 in the form of 2/2. We now have here 2/4. And 2/4 plus 1/4 equals 3/4. So a little play on arithmetic there. Again, this is 1 times that, so the 1 stays in the numerator. We now bring our negative 2, the exponent crosses the division bar, it becomes positive, and then we can simplify that. And since it's an even power, our negative sign will become positive. And 2 to the 4th is 16. And again, this is 1 times that. So the 1 stays in the numerator. The y to the negative 4 comes down as y to the 4th. Okay, continuing with example 2, we're on the next page. We want to make this positive exponents. So here we're just taking it from the denominator, bringing it up to the numerator, x to the 3rd. Here we're bringing the 3 up to the numerator. This becomes 3 to the 4th, which we know is 81. And here, for letter C, we can just change those 2 around. So it would be p to the 4th in the denominator and q to the 9th in the numerator. And by the way, the instructions for these is they only want positive exponents. And the same here. This will be 2 to the 5th as we bring the 2 up, and 5 to the 3rd as we bring the negative 3 down. And 2 to the 5th is 32. And 5 to the 3rd is 125. All right, going on to example 3. Again, the rules or the statement make all with positive exponents. So here, as we bring up the -2 and a 1 up there, that makes this y to the third. And as we bring this up, this now becomes 3x to the fourth. Now in this case, remember there is a 1 there. This will become 1 in the numerator. We're going to bring the -5 down, add it to the 7, which will give us 1 over x to the 12th. Now when you see something like letter D, when you have a fraction that's raised to a negative power, a good little tool is convert this to a positive exponent by taking the reciprocal of what is the fraction. So the fraction in its reciprocal form would be 3 over 2, and now this becomes a positive 3. Now you could have, done that, but it's much easier this way. So this then becomes 3 to the third over 2 to the third, which is 27 over 8. Again, keep in mind, if you need any help, be sure to ask your tutors and your instructors. That's what they're there for, to help. This is meant to help too. Well, lots of stuff in this. It seems to be getting a little more complicated, but again, watch the rules. I'll go over them with you. Now, when we're raising a power to a power, we multiply, and interestingly, the signs of what we're going to multiply apply. So this is a -3 times a -6. This will be y to the 18th. Now this is going to be z to the 6 times the -6. This is going to be z to the -36. But they want only positive exponents, so we have to rewrite it as y to the 18th over, now bring this down, z to the 36, not negative. We brought it down, it became positive. And did I copy B correctly? Yes. There's no negative exponents in there, so they, I guess, just want us to play around. So let's expand this. This is going to be 2 to the 4th, which is 16. X to the 12th times x over here. And this is all over x to the 7th. Well, this then becomes 16x to the 13th over x to the 7th. And as we simplify, we're going to bring the 7 up and subtract it. And that'll give us 16x to the 6th, I believe. Yes. Now, this one here, remember, we could do what we said. If it's a negative outside, just flip this over. So this now becomes b, 3a squared. We're just taking the reciprocal of that. That now becomes a positive 3. So now it's going to be b to the third. 3 cubed is 27. A to the 6th. Now in letter D, a little tricky. Notice we want positive exponents. So when we bring this -3 up, it becomes a positive 3 up here. So this then becomes 4 to the 2nd, which will become 16 in a little while there. We're going to bring this x to a -3 down, and that then in the denominator becomes x to the 5th. We're going to bring the y to the -6 up. There's a 1 there. So that becomes y to the 7th. And I think we can save a little room by just making this a 16. Now, notice if you have something like this, remember we said you could simplify a little bit here. For instance, this y to the -1, we could bring up, and this becomes y to the 2nd, and then this disappears. And this x to the 1st can go up as a -1, and this will become x to the 2nd, and now that's over 1. So we simplified to make it a lot easier. Now we have a -3 raised to the 3rd power. Well, that's an odd number, so that's going to be a -8. X to the 3rd. Let's do that one again. 2 times 3 is 6. There we go. Y to the 6th. Okay. Again, lots of stuff going on, and just little by little, check your work. And remember, if you see an error, that's a little math star bonus point. Okay, I noticed I was even having to count zeros and things to be sure I get these numbers correct. Well, here we're going on to what is called scientific notation. And we use scientific notation in science, in the fields of biology, astronomy particularly, and other sciences, where we have large or small numbers, and we want a way to handle them. Now, the key to it all is that in scientific notation, you have a number that is between 1 and 10 times some power of 10. So this is what we have to do here. And then in our next exercise, we're just going to reverse it. We will have scientific notation, and we'll put it into standard notation. So the key is, where is the decimal point? Well, the decimal point is right here. So I'm going to move that decimal point until I get to this number right there, which is now 3 point something, a number between 1 and 10. So let's see how many places I move it. 1, 2, 3, 4, 5, 6, 7, 8. So now I put the significant digits down, times, and there's a special time sign in your tool palette, 10, and I moved it 8 places. 10 to the 8th. So that is in scientific notation. It's a number between 1 and 10 times 10 to some power. Now in this case, the number is smaller, so I'm going to the right now, and it's 1, 2, 3, 4, 5, 6. It'll be 3. Oh, I could add a point there, times 10. Now, since I moved it 6 places to the right now, these are negative exponents. So when you get negative exponents, those are for the small numbers. Positive exponents are for the big number. Now notice to change it, we went to the left here. Those were positive. When we go to the right here, that's negative. So here's a super big number. I can go 3, 6, 7, 8, 9, 10. Here I'm moving that over 10 places and putting my significant digits down. And that's scientific notation. Here's another small one. 1, 2, 3, 4. Remember, I want to make it a number between 1 and 10. So that will be 8.5 times 10. I moved it over 4 places to the negative 4. Now, we're going to undo this and go from scientific notation to standard notation. Okay, now the key to this is how many zeros or how many places are we going to add, and then fill it up with zeros. So here we have 1.02, and I need 6 places. So I have 2 here, so I have to add 4 zeros. So now when I move my decimal point, I go 1, 2, 3, 4, 5, 6. And that is my number. And I could put commas in there if I like. Again, how many decimal places do I need to move it? And the answer is 3. Well, I have 7.358. I have to move it 3 decimal places. So that's 1. So I have to add 2 zeros. And we usually add a 0 to fix it. Now here we have 1. We have to add 6 more zeros. So 8, 4, that's my 1, and now 6 more zeros. And we can put commas if we'd like. So hopefully you're learning or developing a technique to do this. So we look at the exponent, it's negative 5. So we have to add 5 places. There's 1 there already. So we need to add 4 more zeros. 1, 2, 3, 4. Put our decimal place over, and we usually add another to fix the decimal. So negative 5, 1, 2, 3, 4, 5. And again, if you want to convert it back, here's your decimal. You're moving it 5 places, putting in your decimal to make it a number between 1 and 10. So much of it stays the same. So this is 56, but now this is times 10 to the negative 3 power. Okay. Again, that's still not in scientific notation. So the decimal is there, we move it over 1. This now becomes 5.6 times 10. Now, since we moved it over 1, again, we're adding 10 to the first there, so this becomes 10 to the negative 2. And then if we wanted to convert this into standard form, again, we're going to need 2 decimal places. So we're going to move it 1 over. This then becomes 0.056 is the answer officially as it is in our textbook there. Okay, going on to letter B, and I've just checked it and we are good. Here we're going to divide the 6 into 12, and we get a 2 all by itself. Times, we're going to raise the negative 3 up to the denominator becomes a positive 3 times 10 to the 5th. And again, if we're going to put that into standard notation, this is in scientific notation. Our decimals here, we have to add 5 zeros. 1, 2, 3, 4, 5. And there is our answer. Now we wish you good luck on this section. It's not too hard. A few little things to be careful about. We'll now go on to our last section in Math 1103, which is 5.6.